The real purpose of this is to be able to test the effectiveness of growing with one of these bags in the ground. Now, this particular bag is a PLA, a polylactic acid bag, basically made out of a corn starch. And this is completely biodegradable as well as compostable. So a very interesting product that is rapidly expanding in its production around the world. And they're finding many more uses for this to replace other bags. So the concept behind this is really quite simple. It's to be able to get a flower pot basically for free. In many countries that I travel to where they struggle with growing food, especially among the poor, there's plenty of plastic bags lining all of the fences and running around in the bushes. And the concept here is to provide a useful growing technique where either soil conditions are very poor or where there is very limited water. In most every other situation, if they have plenty of water and good soil, we don't need to be necessarily improving or coming up with a radically different concept. For the most part, they are growing food. So this concept here, I'm going to be testing in 4 different stages, the same exact vegetables and a whole variety of vegetables. And what I'm looking at is I've dug holes and I'm mixing up some dirt, some of the topsoil that I pulled out of these holes, along with some fresh organics to give a really good mixture. And in each of these first row of holes, I'll just be putting the mixture straight into the holes and watering these like I would a typical garden. Now, this is not a rototilled, turned over all of the soil and combining it all. I'm looking at just a single hole that is about the same dimensions as the holes that will be used with the bags. In the next row over, I'm going to be putting a little bit of gravel at the bottom of the bag that will allow for a little bit of the moisture to fall down to the bottom and actually be retained in the bag, but will also allow the soil to breathe a little bit better. In the next hole over, I'll be putting some gravel down in the hole first, filling the bag with the good soil and punking some holes in the bottom of the bag that would allow for drainage down into the gravel below. The last row will end up having sort of a very similar concept where I'll put some of the gravel inside the bag, then fill with soil, putting some holes at the bottom of the bag, then the bag down into the hole. Now that I've got this whole area covered in a weed cloth, I'm going to cut a little hole in the weed cloth for each of the holes that I plan to grow in. Each of these will just be simply folded down into the hole to help minimize the amount of weeds that we see here. I'm covering all of this area because we're planning on not growing in most of it, just in the hole. So there's no reason to let the sunlight through and grow anything else, any other extra weeds to bother us here. The weed cloth will make it a little bit warmer when the sun comes down, but that's okay. Most of the conditions around the world where either the soil or limited water is a factor for growing, quite often having a lot of heat is also one of the contributing problems in that area. So to have this whole area be a little bit warmer than normal is something that I'm not concerned about. All right, now that I have all of my holes cut into the weed cloth, I'm going to begin filling the holes with the different types of test samples that I want. Now, what I've done here with one of these samples is I've taken the PLA bag and I have gravel, a pea gravel, on about the bottom 1.5 to 2 inches, and then I'm filling it with my nice mix on top. I'm going to leave enough of the bag above this so that we can take the bag and sort of fold the bag over itself and create a little miniature greenhouse. Where I am right now in northwest Montana, in the middle of May, we still have freezing or near freezing temperatures at night, and most of the evenings it's down into the 40s. I'm going to take each of these sample bags and just cover them over until I see germination taking place. It will also have the benefit of holding some of the moisture in, which will make it, at least certainly for the beginning part, germination helps provide a really good conditions in there. Even after the plant has begun to grow, we will be able to take these plants and be able to pull them back over loosely around the stem or under the bush, and that's going to help control or reduce the amount of rainwater that comes in here, so I can actually be testing the amount of water each of these bags are requiring. And then we have another bag that's simply going to have dirt go the whole way through it, and I'm going to puncture some of the holes at the bottom, and that will allow some of the drainage in the soil. Some of the holes that I dug have a pretty hard clay. It's, I believe, a backfill from when they did construction on the house. So I've dug down extra deep until I reach that soil so that we can still get a good drainage in each of those spots. The last bag condition will be just like this one with some gravel, but I'll be puncturing some holes along the bottom that will also allow this to drain into the soil. It will produce a little bit less water retention there, but we'll be testing all of these to see what the difference really is. Okay, here we go. I've got all of the holes dug and bags put in. I've added in a little bit of extra topsoil and a little topsoil treatment to each of the different bags here. In this row, I have bags that just have a little bit of gravel at the bottom, but they're sealed. So it will allow for the drainage from the soil, but it will also retain the moisture inside the bag. The next row over has some gravel in the hole, but not in the bag. And we still have some holes on the bottom of each of the bags, so it will drain and have some gravel to make the drainage a little bit better. The last hole condition there is a bag with soil on top of some mixed soil. It's not a heavy clay. It does allow for some drainage, and I want to make sure that we test just soil and soil, as that can be a bigger benefit around the world. The less work you have to do, the better. The desire of this project is to really be able to help people, especially the poor, that are in conditions where they have bad soil, poor soil, no soil, or they have a lot less water, and water is a challenge for them. So when it comes to the simplicity of a bag with just soil, that's my greatest desire to work straight away. The bag here that has no holes in the bottom, has some gravel, that to me is the next best, because it's going to hold the most amount of water, the least amount of waste. And in my test last summer with just some test conditions, this is the one bag that ended up growing all on its own with very little water ever being added. So those are the soil conditions. Now I'm going to plant the seeds, and we'll wait and see what happens for the germination. So I've done the tedious job of planting seeds in each of these rows. I've planted 3 seeds in the desire of having a germination test, be able to see which one germinates the best. And once I do have a good germination, I will pick the strongest seedling from each of the different plants and then pull out the others when they are a plant or a bush that's going to take extra space. Plants probably like carrots, I can allow a few more to grow in that bag. So now that these have all been planted, I'm going to make sure that there's enough water in each of these bags, and I'm going to come back each day and test the moisture level of each of the soil down every inch to about 5 inches, just to be able to see how the moisture is being maintained in the bags versus the ground. So that's it. Now it's waiting time for germination. So it's the next morning. I've come out to test the soil moisture levels. The row that is simply the soil and left exposed on my meter is at a level of 4 out of 10, and each of the bags are at about a 6. We started off with plenty of water for all of these to start with. Don't expect germination yet. That's not what I'm checking for, but we'll be watching the moisture levels in each of these bags and watching for when the germination is expected to occur for each of these. Since some of these seeds are designed for cold temperature germination, I expect some of those to be first. But even with the little greenhouses collected over each of the bags, I'm hoping to see even some of the warmer germination seeds getting a little head start. So really what I wanted to talk about, if you've made it this far in the videos, is why we're doing this and some of the additional benefits that can come from growing in a bag versus just simply growing in the ground. Again, the design behind this is not trying to get all first world countries to start growing in bags. Most people that are gardening for enjoyment or gardening for supplemental vegetables to their salads, this is maybe a harder way to go for many of them, especially if you have good access to water, you've got a hose connected to your house and you've got soil, or you can go to the store and buy extra soil to be able to amend your own. Where this can come in really to be a very helpful to use is similar to the situations that people find themselves in around the world where hydroponics is being promoted. And so this is an alternative, and I believe a much better idea to at least begin to work on to try to develop than hydroponics. Many years ago, I was looking at third world conditions, growing food, and was considering hydroponics to be a viable, if not a really good option. Certainly where there isn't any soil, poor, bad soil, or water is limited, which is the same conditions that I'm attempting to test here. Where hydroponics really struggles, and I include aquaponics, vermiponics, any type of aponic system, those are really first world problems, first world solutions that work really well. In the local area here, I help out a lot in the ongoing operations with a hydroponics greenhouse that's commercially growing tomatoes and cucumbers. It works fantastic. It grows far faster and easier in a controlled environment. Where hydroponics or even the aquaponics systems that are being developed and designed for promotion in third world conditions, where they fail is really what they can produce, how easy it is to produce, and the fragility of the system. So I would challenge any of these systems to see how many of them have been operated purely by the poor in a poor community where they still have their fish, the crops are still going, and the system still functions a year later. The systems can fail quite rapidly. So in a hydroponic system, I challenge the people to walk away from it for a week and see what happens. They also can be very challenging in warmer conditions where the water tends to heat up more and more. You can also get diseases or problems in the water that can develop. And my experience around the world is poor people work very hard just to survive, and what they're not interested in is working extra hard. So just try to imagine yourself, if you were making bricks by hand all day and you came home at night, how much longer do you want to spend in a garden or a hydroponic system, keeping it going day after day after day? Another one of the challenges with a hydroponic system is simply the setup and the cost of setting it up. Now, the promotion side of the hydroponics is really the main selling point is use much less water and grow 3 times the food or 3 times faster. So here's the simple argument against that. If your hydroponic system, let's say, has the entire area and space of my first row of plants, for me to grow in the ground the same amount of food in the same amount of time, I simply need 3 rows in the ground. So if I'm planting one of these rows every 2 weeks with lettuce, I will have lettuce coming out of these 3 rows as quickly as one whole row of a hydroponic system. The other challenge with hydroponic systems is what you can grow and how easy those plants do grow. The primary crop that people start off with and even stay with is lettuce. Lettuce is a great vegetable, it's a great leaf, but it is not the solution to the world's nutritional problems. It's also not a produce that everyone around the world enjoys. So when you're looking at what can you do to help people that are really either struggling to get any kind of food or struggling with the nutrition, lettuce is not providing the complete solution. When you begin to look at other vegetables, there are lots of vegetables that struggle greatly to grow in a hydroponic system. I've got 25 different vegetables that I know that can grow in this situation. And I also, from testing last summer, was able to see that the bags that I was doing some test conditions in we're using about 1/7 the amount of water required to grow in the ground. And that's why this year I'm extending the test to be 25 different types of vegetables that are going to be growing and seeing how much water each of those different types of vegetables take. So the hydroponics system, my greatest challenge and struggle is I've set these up in India, tried to set them up in Kenya, and the systems, even once you get them going, they fail. And they fail a lot of times because when people are stressed to try to figure out how to grow in a new situation, in new conditions, using different pipes and waters or pumps or whatever it may be, when something goes wrong, when it stops functioning the way it should, or when the plants don't grow as well as they had anticipated, the people go back to simply what they know. And you will see these systems failing all around the world. I've seen solar panel arrays put in for poor people in small islands in the Indian Ocean where they have no electricity, and the solar panels have been abandoned years and years and years ago, because as soon as it didn't work, it was torn apart. People sold the parts for what they could get just to get some quick money. I believe that what you will find in hydroponics, if it is left into a poor community, if it's working in aquaponics with fish, I would imagine the first wedding festival that comes along, the fish will be gone, and the system will quickly die. So this test here, doing it with the bags, it's going to be more natural. People know how to grow in the ground. It's not stretching them in the concept. It's actually going to be reducing the amount of work that they need to do. Once a hole is dug, we can continue to reuse the holes. Another benefit of growing in the bags is that at the end of the growing season for the plant, I can pull out the bag. I can take the good soil that I've put inside of there, mix it back in with a compost, and be able to put it back into a bag and start over again in the same hole. So all of the effort that I had in putting all of these holes in the ground is really something I only need to do once. And each year I get to keep reusing it, and the soil I keep reclaiming and improving upon by adding more compost. What that also means is I need a lot less compost in order to put in a great soil setting for each of the plants that I'm growing. I don't need enough compost to be able to rototill into all of this area, even where the roots are never going. So a good story that I have is when I was first working on this concept and trying to see if it would be of value, I was traveling in a remote area in southwestern Madagascar where the soil is basically sand, very dry conditions. And one village I stopped at, sat down with the chief and the elders, and they asked me at the end of our time talking if there was any way I could help them get more water to their village to be able to grow plants, because they were struggling to survive. I changed his question around and said, what if I could show you how to grow more plants with less water? They agreed. They were curious. So I found a bag that was just laying on the ground not far away. I went over, picked up the bag, and without saying a word, I dug a hole in the sand, put it in the bag, poked some holes in the bottom of the bag, put the bag back in the hole in the ground. Then I took a little twig and put it right on top of the bag. And at that point, the chief and the elders all began to clap and cheer and laugh because they already got it. They understood. They were having to walk 1 or 2 kilometers away just to get water from a pump and carrying it in 5-gallon buckets. They're pouring it onto their tomato plants and just watching it all disappear. This was something they understood. They know how to grow in the ground. They could see the benefit and the reduction in their water needs. So this is just a challenging point here for those that are doing hydroponics and trying to promote hydroponics in third world conditions. I'd like to provide an alternative here, and something that I think is a lot easier for people to understand, and something that can have the same benefits but actually additional benefits, in that your crop is able to have a larger variety, and people will understand this concept and be able to grab it very quickly. So that's it. We'll have to wait a little while, and I'll probably send some new videos as things begin to grow and as I begin to get some test results.